Okay, guys, welcome. Yeah, so in this video, I've got book recommendations for you. So like in one of the videos where I had this same background, a viewer, and it was clear that it was a genuine question, asked what the books behind me were. So like I'm not gonna go through my bookshelf, but not everything. But you know, I thought giving you a good math book review would be very helpful, right? And I'm going to present the books in the order in which that you should study these subjects, right? Okay, and of course my number one book recommendation is the Bible, right? Read the Bible. It comes before all of these. And of course, if you've been watching this channel for some time, then that comes as no surprise that I'd make that my number one recommendation. Now, as far as, you know, non-math books, I really don't find a ton of value in them. They're just essentially someone's well thought out opinion, right? And hopefully you're a thinker and you think about life and you know, from the minutia race relations to you know, why are we here? Bigger questions. And so hopefully you kind of come up with some ideas on your own, right? To that end, an interesting side note is that I had this friend who got an engineering degree from Duke, right? And he'd always be quoting somebody. He'd be oh, here's a nice little quote you should read from MLK or from someone else. And I got so frustrated at some point. I was like, do you have any thought of your own? He sent me a quote by Michelle Obama. No offense, but Michelle Obama is not smarter than him. She's definitely not smarter than me. And so you know, she has a platform, but you know, ultimately some of these people are just trying to sell a book too, right? And so despite her having a much bigger platform than I or most other people, it's not like I'm gonna benefit immensely from reading her opinion or take on life. I spent a lot of time thinking about probably the same kind of ideas that she discusses. In fact, there's this great interview on YouTube between Dave Chappelle and Maya Angelou, and I think it's called Iconoclast. And they're you know, they talk about how if you're constantly in awe of these people that are put in front of you on TV or elsewhere in media, then you prevent the possibility of you being big or achieving the same kind of things that they achieve, because you're constantly in awe. You see them as idols. Your only idol should be Jesus Christ. Okay, listen if you've got ears. Okay, and yeah, I got Malcolm Gladwell's book here. I have not read a single line, because it's his refined opinion on race or whatever is I don't think that much more sophisticated than my ideas or my thought on race, or someone else who thinks quite a lot about these things, right? Not just mine. This isn't about me. So let's get to the math book recommendations, right? Okay. If you got your math education in a U.S. high school, then you start with Algebra 1, right? Now, there's a plethora of Algebra 1 textbooks, and really one is not better than another. So yeah, so you know, take your pick for what algebra book you want to use. If you're an advanced algebra student, then Gilfon's Algebra is really, really good. It's white cover with green trims on it. Anyway, so you start with Algebra 1, right? And I'd say the same thing about Algebra 2, which is a course you take after geometry. Now, I've been trying to charge my camera, and for whatever reason it's not charging, so I have to be efficient with this. Good. We're on time constraints, right? But I'm gonna also try to do a very thorough job, since you know, if I'm gonna do it, I want to do it well. And also not every book that I'm going to recommend as I might have said, is on my bookshelf. And so for that reason, I took pictures, or I saved some photos, because like these books are really like books I'd swear by, right? So again, if I'm gonna do it, I want to do it well, right? Doing it and doing it and doing it well. anyway, so after Algebra 1, right, for geometry, this is the book, right? This is the best book for geometry. The most elite private schools around New York and New York City and the suburbs, right? Those schools all consistently use this book as their main geometry course book. And no wonder they do that, because, well, it's incredibly well written, and these are some reasons why it's very well written, right? So first of all, there are about 200 proofs in the book, I'd say about 200, and every topic is treated very rigorously, and there's like this very elusive, difficult geometry question that like the YouTube channel PreCalc shows you how to solve. And I actually like wanted to make a video for it, and I realized that I can't do better than him. And anyway, that famous question is in this book. So every like really famous, important question that you'd want to see in geometry is in this book, in addition to those rigorous, very fun proofs that Harold R. Jacobs shows you. And so basically the rigor, along with like the all-encompassing like perspective on geometry. I actually have Euclid's Elements, which, as you might know, is a very popular geometry book because it's like very famous, right? Euclid's Elements. Anyway, this is kind of like Euclid's Elements meets a standard high school geometry text meets like proof-based rigorous geometry education. And like before I conclude, on page 688 starts like before the appendix, he's got like some really fun topics that he covers as extras. And also, while I'm at it, let me tell you, like most geometry books don't talk about incenter, circumcenter, and that kind of stuff, right? And yet Harold R. Jacobs has dedicated a chapter to all those items. So 688 I said, right? I didn't lie. So chapter 16, non-Euclidean geometry. But wait, what standard high school geometry textbook has non-Euclidean geometry as part of it, right? Like, and this book surprisingly can be found online free PDF, chapter by chapter. So search for it. Lucky you are, because, well, yeah. Okay, so before I talk too much like Yoda, let's move to the next book. I guess I could toss this on the ground now that we're done with it, right? Okay, so as I said, Algebra 2, just like Algebra 1, like, you know, take your pick of any book and you'll have a standard Algebra 2 education. Okay, there are a couple of books that, you know, I have in the past used, but I don't remember them, and I guess they weren't that noteworthy. Okay, so for pre-calculus, which is a course you take right after Algebra 2, and by the way, this book contains prerequisites for pre-calculus, and therefore treats some Algebra 2 items in it at the beginning, right? And treats them rigorously is what I meant. Anyway, this is a really, really awesome book. Again, most of the elite private institutions, private high schools in New York City in the area, like use this book as their standard pre-calculus textbook. Well, I can't say enough about it. It's like incredibly well written, and yet it's very brief. Like every topic is like fit like a page or two, maybe 3, sometimes 4, but like, you know, it has some really, really cool questions, including the guilt tethering problem that I shared with y'all, and of course it will also cover you for trigonometry. So it's got a lot of trig in it, matrices, every like pre-calculus and trigonometry topic you'd want is in this book. An interesting background and side note therefore is that like I worked with someone who had taught at my first private school for about 30 years at the time that I met him. He was the first department chair or whatever, and he was the department chair for a long time before the person who chaired it when I walked in started chairing it. Anyway, he got tired of the department chair work, but this guy's like a fantastic teacher, and he edited this book. And so curiously, of course, I asked him like, wait, if you edited it, why didn't you write your own book instead of editing someone else's book? And he was like, because like the guy who authored this book basically like spent all of his after school hours writing this book for years, and that guy is Richard G. Brown, and it's a McDougall little book. Advanced Mathematics is what it's called. It's the best pre-calculus book and therefore trigonometry book that I could recommend to you. Yeah? Okay, cool. And why it is in my collection? Who's got room for junk, right? Of course, then that brings us to calculus. Now, if you want like, you know, a first-time great calculus book, then James Stewart's calculus book is unbeatable, right? And so James Stewart, I recommend him for calculus and multivariable calculus. And by the way, I'm not getting paid from any of these people. It's just like a genuine desire to share what I think is awesome. And I swear by these books. Like if someone comes up with like a better list of books for our high school through college and a little bit of grad school than what I'm listing here, then like, yeah, like tell me who that person is. Again, James Stewart for calculus and multivariable calculus. So then it starts to get into like math major courses, because well, after multivariable calculus, you're really like taking college level courses. Multivariable calculus, like it should be standard in high schools, because well, it's not that hard. It's just calculus in 3D, right? So then you start getting into theoretical math after multivariable calculus, right? And so as a foundation, after multivariable calculus, you need to take analysis. Now, for analysis, in my top 3 books of all time, I already mentioned a book by Michael Spivak called Calculus, right? Now, I took a picture of the actual book. This is the solutions manual to it. And by the way, like I learned from a friend who's like super talented in college, like studied all the time. I think he's a professor at UPenn now or whatever. Anyway, I learned from him that like it's okay to use solutions manuals, because he rationalized it by saying, well, like if I'm stuck, then I can study from them. I'm not really cheating. And so I kept the solution manual to Michael Spivak's book, but I don't have the original now. It's gotten a facelift. The original looks like this. I had the original somewhere, not important. Point is that like, although it's called calculus, it's actually an analysis course book. And in fact, at Fordham University, a colleague of mine told me that they used Spivak's book as her first graduate level analysis book, which is kind of a little silly, but it's like a really good undergraduate foundational analysis book. But then we get into like a legit analysis book, right? For a legit analysis book, most of the top US institutions, NYU, blah, 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 like they use this book by Wade, right? And so it is called Intro to Analysis, and it's William R. Wade. Again, most of the top institutions use this book. So, you know, like this is like actually dedicated to analysis, unlike Spivak's calculus book. So this is a great way to learn analysis, right? Okay, cool. Now, analysis is an important foundation to everything else you do, right? Like, what does that mean? Like, well, what other courses do we have? Number theory, linear algebra, discrete math, and abstract algebra, and of course, complex analysis, my favorite. So for all of these courses, and topology, right? For all of these courses, and many more. But for all of these courses, analysis is a very, very important foundation. Once you finish the course in analysis, you can take all these other courses that I named in any particular order. Of course, a specific order makes more sense than another. And so I intentionally designed this video that way so that it gives you structure, right? And so a really good discrete math book is Kenneth R. Rosen's textbook. Like, I mean, he touches on a lot of subtopics, including modular arithmetic, probability theory, and much more. So this is a great, great book. And as you can see, it's really dense. So there are tons and tons of topics, including RSA encryption, blah, blah, blah. So check out this book. You can learn more about it on your own. As I said, I'm kind of constrained time-wise, and so I gotta try to go through these efficiently. Now, so then that brings us where? That brings us to the other advanced undergraduate math courses, right? And so what do I go to next? As I said, after analysis, the order doesn't really matter, but next one that would make sense is number theory. And for number theory, this is the book that I used and I strongly recommend it. It's incredibly well written, and it's simply called The Theory of Numbers, an Introduction to the Theory of Numbers. And this is the 5th edition that I just showed you a picture of, and it is by Ivan Niven, Herbert Zuckerman, and Hugh Montgomery, right? Okay, so here it is. Fantastic book, very well written. Okay, and then I guess we gotta go to abstract algebra. Abstract algebra, I swear by this book. I had 2 copies of it. I swear so much by this book that a friend asked me to borrow it and never returned it, and I don't know what happened to my other copy. And this abstract algebra book is by John B. Fraley. It's a fantastically well written book. Like, it's so delicious. It's such an easy, fun read, incredibly well organized. It's like really awesome. Yeah? So John B. Fraley, that's for abstract algebra right there. Okay, cool. And so then what's next after that? Of course, my favorite math course, complex analysis. Now, I heavily borrow from this book, so it's kind of like shameful for my complex analysis videos, that is. So it's kind of shameful that I even recommend it, but this is simply called Complex Variables, Introduction Application, and it's by Albowitz and Focas. Albowitz Focas. This is what it looks like, and there's a free online PDF copy of it, so lucky you, hunt it down, right? Okay, here it is. Okay, cool. So that then concludes undergraduate mathematics. So I took you from high school, beginning of high school, to now the end of undergraduate mathematics. Yes, there are numerical analysis and other math courses that I can fit in, but these are like the math courses, like, so you know, synthesis, right? Okay. I mean, ain't nobody got time for like all of that, right? Now, of course, remember, I recommended and swore by John B. Fraley's abstract algebra book. That's a foundation undergraduate math textbook. But if you go to grad school, this is kind of a supplemental book, but this is a really good book. And it is called A Book of Abstract Algebra, and it's by Pinter, right? Charles Pinter. Okay, cool. And then we go to real serious abstract algebra. So we're at graduate level now. Like, funny enough, my undergraduate institution called the abstract algebra course basic algebra. So for someone who's untrained, they look at it and they think like it's like algebra 1 from high school or something. It's called basic algebra. Anyway, that's to make fun of the title here, and it's algebra, and it's by Hungerford, right? And there's a series of these books by Springer. Like, they look exactly the same. They're like yellow and white and whatnot, but this is typically used in graduate school. A really good book for graduate abstract algebra, right? Of course, there's some overlap between Fraley and this book, but this book is like much more advanced. Now, this is what I recommend for linear algebra. For my linear algebra videos, I again heavily borrow from this book. It's incredibly well written, and importantly, notice I didn't mention linear algebra as an undergraduate math course, but technically it is. It is both an undergraduate and graduate level math course, linear algebra, that is, right? And so you can use this book for both. Because it's advanced enough that it would fit into graduate mathematics courses, but it's also written well enough and like in a way that's consumable that like you could use it as an undergraduate text. I used it in my graduate courses. I think it's written by a person from NYU, or at least one of them, and it is Stephen Friedberg, Arnold Insel, and Lawrence Spencer Insel. One of them was at NYU, like while I was taking this math course at NYU. But anyway, that's kind of a side note, not very important. Okay, so we go to real analysis, right? Why don't things just work, right? Okay, anyway, some technical glitches, and this is why you should applaud anyone who's making math videos for you or sharing it. At this point, like, I'm doing it for the same reason Eminem is rapping at like 45, which is for the sport. Not that there's any money on YouTube. But anyway, for real analysis, this book by Barry Simon is the book, right? Like, for example, in it you can find, and this is just part 1 of the book, in it you can find, you know, the usual analysis ideas treated incredibly rigorously, but also things like LP spaces, right? Duality of LP, the separating hyperplane theorems, the Banach analog theorem. Like, this is why I decided not to get a PhD in math. Well, there are other reasons, but mainly because at some point you only can talk to like 15 other people, and like, no thank you. But anyway, as we have to wrap this up, here it is. This is a really rigorous, hard to understand book, but you know, all math requires a lot of time to process and so on. So if you take the time to really study, then you'll understand it. Now, notice that I didn't recommend any books for differential equations. I haven't come across any that, like, you know, that was worth being in my collection. But going back to undergrad number theory, some miscellaneous items is my last couple. This book, Introduction to Number Theory, a friendly introduction, I should say, by Silverman, is a really good book. It's light, as you can see, it's not very thick. And The Book of Numbers by John Conway and Richard Guy is a great book. Also, Conway is that kind of like, no one is crazy, so I don't want to call him crazy, but out there, a mathematician who invented the surreal number system, right? Okay, so we conclude this series, or this video, it's not a series, it's just a video, this video with this book. I hope you enjoyed it, and yeah, keep watching. Take care.